I share my screen, guys, and then we can begin? Okay,
Yeah.
so I'll share my screen. Can everyone see it? In full screen mode? Yes?
Yes. Yep.
Okay, perfect. Okay, let's do this.
All right. Good day, Australia. My name is Eva, and I am here with Yuniki, Sumit, and Marcel. We are Team Pyropower, and we're going to share with you our global vision for the 2020 Global Business Challenge. We will start with sketching an overall picture, one that's also very important for Australia. Artificial fertilizers required for our current agricultural practices account for 50% of greenhouse gas emissions in the sector. Organic farm waste produced through these practices is the biggest source of waste and pollution worldwide. Lastly, every second we lose 3 acres of farmland, land that otherwise would be used to grow our food.
And that's where Pyropower comes in. We work with agriculture communities all around the world to sustainably manage waste and produce a natural soil conditioner. Okay, this natural soil conditioner, we call it Biochar. And we believe this is the missing thing in our global cycle. To give you a few examples, biochar can increase crop productivity, decrease a farmer reliance on chemical fertilizer, and also improve the CO2 capturing ability of the soil. So, we believe the problem of waste, energy, and agriculture are interconnected. So we are here to promote this circular economy. Okay, to begin this journey, a proof of concept, to pilot, to commercialization strategy is planned, which is allow us to identify a target market. Okay, Australian national target state to recover 80% of all waste stream by 2030. And Queensland, 1.2 million tons CO2 greenhouse gases emitted by sugarcane industry. And this is explained by the fact that 90% of Australian sugarcane is grown in Queensland. Okay, to prove that our vision of circular economy can work in a small scale, we begin to try our technology, power reactor, to a sugarcane farmer. We expect the farmer could start to manage their waste and produce biochar and utilize the biochar to their land. And then 2 things that we would like to identify in this phase is the first one, valorization of waste, and the second one, of course, the biochar itself. And the directly associated to SDGs goal, especially number 12, about responsible consumption and production, and the 13, climate action. Okay, in Queensland, per year, 3 million tons of sugarcane trash is left on the field. For comparison, only 25,000 tons of food waste from cities is produced in the same year. And also, our proof of concept phase we will conduct in Whitsunday and Mackay in the Queensland, of course. Okay, let me tell you about our basic business structure. Throughout our project plan, Pyropower keeps building upon this structure, so keep it in mind. And our proof of concept is based on our relationship with the national stakeholder we identified.
These are our national stakeholders. The Queensland Farmers Federation allows us to tap into a large network of farmers, our customers, and sources of sugarcane trash. FarmChar is our link to an established network of biochar buyers in Australia. This party will help us connect these buyers to our biochar platform. BioGrow, lastly, is more of a direct biochar customer who uses biochar in their composting mix. This is the timeline for the proof of concept phase. From December 2020 onwards, we start a demonstration of a small-scale reactor that converts sugarcane trash into biochar. Starting from July 2021, we start planning for the pilot project. The most important outcome that we want the proof of concept phase to have is to boost the biochar economy and turn farmers into local entrepreneurs. Here you can see a case study from Bangladesh, where smallholder farmers package the biochar they produce and sell it off locally. We want to see the same thing happen in Australia on a larger scale, and this is how we envision it. We now expand based on 3 learning outcomes from the proof of concept phase: the valorization of waste, utility of biochar, and because Shell is on board, we want to learn about the farmers' energy demands. Why energy? Agriculture is intensifying because soon we have to feed billions more people on this planet. Consequently, there is a higher energy need for the increased production of foods. These problems are again very interconnected. Currently, only 21% of Queensland energy production is from renewable sources. With our solution, we help Queensland reach its target of 50% by 2030. This is what the next phase, our pilot, will look like. We will partner with 3 sugarcane farms who will all use their own decentralized Pyropower reactor, producing 700 tons of biochar and 1 gigawatt hour of clean energy per year. With our own ICT platform, we offer farmers an easy-to-use place to sell their biochar to a variety of interested parties. How does Shell come in? Shell discards 50,000 oil barrels every year. What can we do with it? We see this problem as an opportunity. What we can do is to collect these barrels and use them as building blocks for our waste processing technology that produces energy and biochar. Shell wants to invest in renewable energy and already does so by investing in natural ecosystems that produce carbon credits. Carbon credits can be procured when using carbon negative solutions or technologies. Here you can see what carbon negative means: low CO2 production, but capturing more and storing it in the soil through, for example, biochar sequestration. This shows that Shell's company goals are in line with Pyropower's carbon negative vision. Under the Australian emission funds, 3 million tons of soil carbon sequestration is expected over the next 10 years, and only farmers can deliver this. This means carbon farming in Queensland is needed. How this works in practice is when farmers change their management of agricultural residues, regenerate their soils, and improve soil carbon, they will get funded by the Queensland Land Restoration Fund. And there's a huge potential for biochar here. The market for biochar to use this funding scheme is estimated to be around $35 million a year.
We built for a pilot based on a Pyropower structure. A pilot project is mainly designed around stakeholders such as Shell and Queensland's Farmers Federation. Pure Earth helps us realize the pilot project by issuing carbon credits and facilitating their trade. The activities and relationships we share with our key stakeholders for the pilot are listed as follows. We aim to help the Queensland government fulfill its resource recovery activities and renewable energy targets. As for Shell, we would like to develop carbon negative technologies for them closely aligned to their mission. Overall, we want to help our stakeholders create a large socio-economic impact and decarbonize the economy. Let me walk you through the numbers behind our pilot project. Currently, farmers pay $45 to $105 per ton to manage their agricultural waste. Instead, if the farmers use our solution, they have benefits of increase in crop productivity, negligible energy costs, up to 40% savings in water irrigation and fertilizers, income from selling biochar and using it as a basis for carbon farming. So, what is the investment case for a group of farmers? Currently, without pyrolysis technology, they incur a cost of $450 per ton for their energy consumption and waste management. But if they use our Pyropower technology, they instead gain a profit of $320 per ton of waste. To give an example, for farmers generating a monthly waste of 5 tons, return on investment on our technology is estimated to be 4 months. We created an estimated timeline for a pilot project for a period of 2 years. We aim to complete our first pilot by April 2022, and by July 2023, we aim to successfully set up 3 on-site pilot projects. How do we compare to the current pyrolysis technologies? We understand the technologies have high CapEx and OpEx and are highly centralized compared to our flexible plug-and-play solution. Additionally, the decentralized and affordable nature of our technology makes it a low-risk investment. The current biochar producers are dependent on a mono waste stream, making this dependency highly risky, while Pyropower scaling up solution is more decentralized. We use a bottom-up approach to empower the farmer community, providing them an incentive to use our services thanks to our stable biochar prices. We have successfully implemented this strategy in Indonesia, where we help tobacco farmers gain value out of their waste by producing biochar and clean energy.
In the past year, we have connected farmers from a variety of places around the world via our Biochar platform. For your reference, you can have a look at carbonmarket.nl. It showcases what type of waste these farmers using our solution manage, how much biochar they produce, and how much CO2 sequesters through this process. This is how our multi-sided ICT platform works. In short, it is a place for biochar trading. We help farmers procure carbon credits for their biochar produced via a third party called Pure Earth. That biochar can then be sold on this platform to a variety of parties and industries. You can see how it can be used in the horticulture industry, for example, as a growth medium or a replacement as peat, in livestock farming to reduce methane emissions from cows, and even in mining to rehabilitate old mine sites. And this is how the business model of Pyropower looks like. Pyropower provides the reactor to farmers, with which they process their organic waste into biochar. The first time, we collect the biochar and we certify it by our partner Pure Earth. Through us, farmers directly receive a large part of the sales of carbon credits from companies that want to offset their greenhouse gas emissions. As soon as it is certified, the farmers themselves can sell their own biochar using our Biochar platform. Pyropower earns a small fraction of each biochar sale here. All in all, this model shows Pyropower acts as the middleman between farmers and the users of their outputs. The great thing is, our business model can be applied to any source of organic waste and to any country in the world.
So with this business model in mind, and the engagement of Commonwealth as the pilot project, we see that the largest producing sugarcane countries in the Commonwealth is actually India. Australia is third. So in order to take us from pilot to commercialization, we take the approach of risk mitigation. Here we identify 4 main risks, and I'll explain to you the process about how we mitigate these. So for the first two, too much competition for sugarcane waste in the region, and that compost companies like Biogrow will not accept our biochar. We reduce the likelihood of these 2 factors based on the fact that there's less competition in India because the go-to solution is on-site burning of their organic waste. There is no other treatment process. In India, afforestation carbon projects are already popular, and there are many other avenues for biochar application, including livestock waste management and affordable water treatment. For the fact that farmers won't use biochar, which means the biochar demand is not so high in that local region, and that farmers circumvent the biochar platform, we reduce the likelihood and impact of this respectively, based on the fact that on the far right, you see Australia's farms are the largest globally. And then you see on the far left, you see India in developing Asia, which is really, really tiny. So based on this fact, India farmers are more experimental and less risk averse to changes in your soil using biochar, and biochar really makes an impact on their crop production. Secondly, because smallholder farmers' income is about 1/7 to 1/12 of that of Australian farmers, the biochar income really makes a difference in their lives. So this is the new risk map when we want to commercialize. And we introduce a few more risks, including lack of government subsidy programs and organized economy for the Biochar platform. And India is also extremely prone to droughts, which is an environmental threat. Lastly, because of the price of the technology, we are dependent also on a group of farmers for cost splitting. If two farmers share the same reactor, the cost of the reactor already decreases by 50%. So you can imagine if there's 5 or more farmers sharing the same reactor to manage their waste. So this is how we really take on from pilot commercialization. We have this business structure in mind, and it gives us the opportunity to target any new market. We can generalize this structure by always first partnering with a farmers association. And this is to really reduce the fact that we can have direct access to a cluster of farmers and already have a direct access to where the organic waste streams are. And we always make sure we have two outputs of where our biochar can be applied to. First is our biochar platform and local economy. And then we always have a direct application, so farmers always have somewhere to sell their biochar to. In general, this is how it looks like. We start with the proof of concept, and we move on to the pilot. This forms our beachhead market. And then for commercialization, we move on to the greater Queensland region. How this looks like in the bigger picture, we can replicate this process from proof of concept to pilot to commercialization to any new markets. For example, when we want to go to India, we start with Punjab first. And similarly for Indonesia, we start with Java, we go on to Kalimantan and Sumatra. By 2025, we aim to have sold 1,400 reactors, and we aim to have managed 700,000 tons of biochar. 40% of this will be used by the farmer back on the farm, and our platform is estimated to manage about 50% of this. By 2023, we aim to have the shell injection of capital. 2024 is when our biochar sales really start to rise. And by 2025, we aim to have a net profit of $5.6 million. And this is really how we progress from proof of concept to commercialization step by step. First, we identify the valorization of waste and the utility of biochar, and we came up with a very basic business structure. By the time we get to the pilot, we introduce renewable energy and carbon farming for farmers, and we build upon this basic structure. By the end, when we reach commercialization stage, we generalize this framework so that we can identify newer markets in the commercialization phase. So with the addition of these stakeholders and the SDG goals we touch upon, and this generalized business structure, we are set to make a global impact. So in short, in places where waste, energy, and biochar coincide, that's the sweet spot for value added. Adding biochar to 10% of global cropland could actually sequester 29 billion tons of CO2, and we believe this responsibility lies with the 1.5 billion strong smallholder farming population around the world. Our vision by 2030 is to empower 10 million farmers, manage 50 tons of organic waste, and sequester 125 million tons of CO2. And this is really the team to do it. We are a team from the Netherlands, from the Delft University of Technology and the Wageningen University, both globally acclaimed universities for bioenergy and agriculture respectively. Myself, I'm the CEO, Eva is my COO, Yuniki is our lead researcher and environmental engineer, and Sumit is our lead engineer. And we have Dirk Rokaerts, the profile leader of energy from biomass, from sustainable energy technology from TU Delft, taking along with us on our journey. Finally, we believe that soil security equals food security. And this is the global impact we want to bring to the world. Thank you very much.
Good timing. So we'll start off with questions. We start in the middle this time. Mark.